Almost the weekend. Happy Staff Appreciation Day. Doesn't help you any, but it makes my life so much nicer. And thank you to any parents that were involved in the forming of it today. But we are in chapter 10, and we are so close to a test. Can almost taste it, and you guys can almost taste it probably too. So it's next Tuesday, the test. I think the calendar says Monday. I'm moving it to Tuesday to make everyone's life a little bit better. But listen carefully. What have I been trying to have you do all chapter long? Remember things like, hey, is this guy important? Isn't he from section 10.1, the line guy? Talking about the inclination dude who is always positive? Haven't we talked about this formula too? The angle between formula? And, didn't we even talk about a couple days ago, I think it was Monday, about how standard form ax plus by is c could be given to you, but we don't like that form. We go to the y equals mx plus b to say m's. And then Matthew helped us out because he was trying to get the tangent inverse in there, because to get theta, what do you have to do at some point? Tangent inverse in degree or radian mode. That was section 10.1, but what else was there in this chapter besides 10.1? Well, we had all these guys, but we moved next to the parabolas. We're going to the curvy guys. Parabolas and then ellipses, which sometimes can be circles, and then hyperbolas. And somewhere along the line, maybe we have some degenerates, right? This big old standard form equation. So for parabolas, question, parabolas, was there a yellow box? Yes. And with the yellow box, was there particular standard forms that would be super helpful to know? Question, who's P? Distance, good, between the focus and the vertex. And it's also going to be the opposite distance between the vertex and the directrix, right? So P says, where's the focus? So if P is positive, zoom, it's up. If P is negative, zoom, it's down. Well, that's only when x is squared. Where's the focus? If P is positive, zoom, it's right. If P is negative, zoom, it's left. But that's only when y is squared. And we have certain points for foci that you could memorize or you could understand. You're either adding to the y or adding to the x. And the directrix is the line, the other direction. And then we talked about how you're going to probably have this coefficient dude that you're going to have to set equal to 4p, right? And I was trying to do examples, not really there. Did I not do it? No, I did. Didn't I? No? Ah, there we go. Examples, and then we did some homework questions too where I was making sure to highlight and say, remember, you have to take this and go look for P and then use P to go ahead and graph. My clue is always, or my hint, my directive is always, okay, this is a complete the square problem, but to try to get a graph as soon as possible to help yourselves out when identifying stuff. Review completing the square. Ooh, there was that nasty tangent line guy. Don't worry, if he's on the test, he'll only be one question, not long answer, okay? If he's on the test, he'll only be one question, not long answer. Then we went to section 10.3, and 10.3 said, hey, there are also not just lines and parabolas, but also ellipses. Question, oops, wrong way. Do ellipses have, where's my mouse? Yellow boxes? Yep. Do the yellow boxes have standard forms? And who is A? Always, always, always for an ellipse. It's how far, good, from the center to the vertex. A is the center to the vertex. Hey, guess what? In hyperbolas, that's what we're doing homework on right now, right? Grading homework. Wasn't A the distance from the center to the vertices again? Yeah. A is always the center to the vertices, but guys, A is different depending on the shape. In ellipses, A is always the what? The major or the bigger guy. For ellipses, it's all about who's bigger. For ellipses, it's all about who's stronger. For ellipses, it's all about what's the major. To go from the center to the vertices, and then that determines our major axis. So if A is under X, I'm moving horizontally. If A is under Y, I'm moving vertically. Wherever the bigger guy is determines where my vertices will be along, where my foci will be along. Whoever's bigger determines all of that. Hyperbolas are different, but we'll talk about that in a second. How do I get to my foci, which are inside the curves? I need to do C. Good. And C has its own formula of C squared equals A squared minus B squared, right? Cool. Vertices, I go out A from the center and I can make my points. Foci, I go out C from my center. Depending on the orientation, you're adding to the X or the Y. After section 10.3, then what? Oh, there was that random, you guys saw them, right? Eccentricity, C over A thing. Hyperbolas. Do hyperbolas have a yellow box? Yes. All right, so let's talk about him real fast. I have two different standard forms. The difference between ellipses and hyperbolas is the minus and the behavior of A. Question, does A move or does A change? No. It's not about what's the bigger number, and some of you might have struggled with this last night. A is not the bigger number necessarily in hyperbolas. It's not about who's bigger. It's about who's... Ooh, there's a life lesson in this somewhere. Is it about who's stronger? Is it about who's more positive? Is it about who... Anyway, we'll come back. But A is about who's more positive. Who is the positive one? Who comes first? So, sometimes X, and if it is an X, what am I doing? I'm moving everything horizontally, right? From the center to the vertices, from the center to the foci, and then the little branches even look like an X. What happens if Y comes first? Okay, fine. Move everything, not horizontally, but vertically. So I'm adding to the Y's instead of adding to the X's in all my points. I'm going from the center up to the vertices, from the center up and down to the foci, and then my branches are up and down. Remember? It's like a Y. Right? It's like a Y. Okay. So, wasn't there something else? Oh, yeah. Distance between center and the foci, which are now outside, right? Farther away. Still inside the curvature, but going the opposite direction from the center. I need to go farther. So what's C squared equal to? And then the very last thing is that I bet we might need to refer to at least at 1 or 2 times in homework our asymptotes. That's what we didn't practice a lot, right? But asymptotes, equation of a line, what form of a line is this again? Point slope. Y minus y1 equals m times x minus x1. My x1 and my y1 can be my whose hk in a hyperbola? No. Center, good. It's 1 point. Remember, there are 2 vertices. Hk is the center, good. And m is slope, and how do I find slope? Well, I use a, which goes up to the vertex, but I also need b. And if it's A is rise, B is run, then it's A over B plus or minus. And if it's A is run and B is rise, okay, fine, then it's plus or minus B over A. All right, cool kids, here we go. We're ready to tackle homework. So section, lo siento, 10.4, here we go. Number 6 should match with C. Number 8 should match with D. Number 10, let me give you a second, but from those clues, you were supposed to figure out that A was 4 and C was 6. Now, they rearranged their formula, guys, but after you solved C squared equals A squared plus B squared, hopefully you got the square root of 20, which is root 5, but if you plug it in your formula, it's just a 20. It doesn't have to be stressful. B squared is 20, so you can just plug in 20 for B squared. And hopefully you already figured out that A squared was 16. Why does X come first? Well, hold on. Who's my HK? 0, 0. Because what's in the middle of plus or minus 4? 0 and then 0. So that's what's going on. And then horizontal. Did you guys figure out it was horizontally away? So that's why X comes first, not Y. That was still easy back then. Well, if you didn't draw a picture, it might have been hard. Let's keep going. How about number 26? Oh, for 26, they gave you the equation, yeah? Did you guys get your center of -3, +2? Your A was 12, because it's what comes first. Yeah, he was bigger, but that wasn't the point. He was positive, as far as the term was positive. A was 12, B was 5. You could find C pretty quickly to be 13 using the formula. Then you just have to, I would say, go to the picture and realize, okay, if X is first, I start at my center and I go out, horizontally away. So I'm going to go out 12, bloop, bloop, on either side. For my foci, I'm going to go out 13, which would only put me 1 more. And maybe you guys could find your points without using formulas. But maybe some of you are realizing formulas are the better way to go. Why am I talking about the better way for your brain? Because what do you need to be preparing for? The test. Well, yeah, let's come back. The test. Final. The test. It does. So if we're preparing for the test, what are you not going to have? Right. So therefore, you need to be able to make it work for your brain. Unless you think it might be nice to have formulas on the test. But we have been working awfully hard to make these formulas make sense. So if I was, do you guys remember the one time I've let you have, well, 2 times. I've only let you have formulas on a test besides the final, twice. Do you remember the 2 times I did it?
Vectors.
Vectors, because it was a crazy hard, tons of stuff section chapter, right? And I was like, write down examples. Please write down examples, and some of you didn't. Well, okay, vectors. What was the other one? Because there were so many of them. And it was going to be so easy for your brain to get confused on the test, right? But do you remember what we had the day before?
Oh, yeah. We'll have reveal homework. I'm good at that.
So here's the idea. Would it be better for your brains to have a day just for working out the formulas and then you get them all on the test to be able to look at and not have to stress about? Or would you rather just have one day and one day only of testing and you just come and do what you can?
2 days.
Yeah.
2 days.
I'm thinking that might be easier in your brain. So wait, if I move the test to Tuesday, maybe it was because I'm trying to let you have a formula quiz on Monday. Well, here's the deal. The formula quiz doesn't really need a review, I don't think. It's just know the yellow boxes, right? No, I know. But the formula quiz, I don't think it'll take all of class. So we're going to review half day Monday. And this next section, or this last section, which I haven't written up on the board, I apologize. The homework is actually due, could be due tomorrow. I'll probably give you till Monday just to give you grace, but I'm having the review pop up in Google Classroom tomorrow. We'll probably do a half-day review tomorrow, too. Does that make sense? Okay. But we'll go over review questions on Monday after the formula quiz. So wait, what am I telling you to have for Monday? Just the yellow boxes. Now, are there some formulas that everyone has to memorize? M equals tangent of theta is equal to c squared equals a squared minus b squared sometimes, or a squared plus b squared, other times e equals c over a. Like, are there formulas? Yeah. Have some of you just been drawing pictures for other things? Yes, but are there standard forms that you needed to reference? Formulas, right? Okay, so start thinking yellow boxes, start pondering, and I've been trying to, as best as possible, keep reminding you of them, so it's not like you get to the end of chapter 10 and say, wait, what? Some of you still do that, but that's your own fault. Okay, so, yeah. Well, I'm thinking this one, couldn't it just be y minus 2? You just add the 2 to the other side? So the one I gave you was y minus y1, so y minus your 2 from your center. And then x minus x1, x minus h. And then plus or minus. Now remember, you have to take rise over run. So you can't just take him over him every time. You have to take the y guy over the x guy. So just take my form. And if you guys are wondering, sorry, I know some of you aren't auditory, so I'm telling you what to do and you're like, I don't know what she's talking about. My formula would say y minus, you should have taken the k, equals plus or minus the y guy, 5, over the x guy, 12. 5 over 12. How do you go from mine to matching to theirs? Just add 2. Yeah, so they just rearranged it a little bit to get y by itself. Yeah, because it depends on the formula. So remember for me, I was saying plus or minus. In this case, A is always the first guy. So when I say the y guy over the x guy, isn't b under y and a under x? But if I had the other one where it was y minus k, see what I'm doing? And then x minus h. This one, m would have been plus or minus the y guy over the x guy. So technically, the y guy, x guy makes more sense. But there are the b's and a's that can kind of go along with it, depending on which one you're doing. Have you guys started grading 42 yet? 42 is kind of nasty. Did you guys figure out it was 64 and 36? Or did you think it was 16 and 9? If you guys thought 16 and 9, you weren't that far off. You were so close, it kind of hurts. If you thought it was 16 and 9, you're so close, it kind of hurts. They told you the foci were plus or minus 10, which was great for figuring out that your center was 0, 0, right? And great for figuring out that you had to start with, this was a horizontally. I'm being lazy, I apologize. Y minus k, I'll slow down just a little bit. Okay, because it's horizontally apart, I know the x comes first. Because of the foci being centered around 0, 0, I knew 0, 0 was my center. So I could have pretty quickly gotten to x squared over minus y squared over, but the problem is they only gave me a distance clue of 10, of C. I know. C is the foci, and it's not A or B. Well, that stinks. I want A or B so I can plug in my formula because I have this nifty-difty C squared equals A squared plus B squared. But I can't just plug in 10. I mean, I can, but I don't know A or B. So what was the other clue? The asymptotes have a slope of plus or minus 3 over 4. So didn't I just say a second ago the asymptotes are the y guy over the x guy? Oh, easy. So the y guy must be 9 and the x guy must be 16, 3 squared and 4 squared. Except, does 3 squared and 4 squared get me 100?
No, it does not.
9 and 16 is 25, so pause. This is why I try to show you for ellipses that little, oh, sometimes things reduce. Reduce. 3 over 4 didn't have to come from 3 over 4. Couldn't 3 over 4 have come from?
6 over 8.
That would have been 3/4. Okay, let's check it. So how does 6 squared
36.
and 8, 36 and 64 is 90 and 100. Is the slope still 3/4? Yes, it is. But using 3 and 4 as my actual A, actual B doesn't make sense with the clue they gave me. So therefore, they did this whole like notation-y thing. But long story short, to get 100, you can't use 3/4. You got to use 6/8. So therefore, 8 squared, 64. 6 squared, 36. Is that cool? I knew there was a tricky one coming. I just accidentally went over it a day early. Well, maybe it helped a few of you, maybe it didn't. But I think it made this make a little more sense. Is that good?
So it could be any number have the same ratio.
Yeah, but if they give you a foci clue, it has to fit that clue. Yeah, yeah. How'd you guys do on matching at the end? Did you notice that the book, hold on, the book has like this clue page thing for conics, doesn't it? Did anybody go looking?
Yeah.
Right here. General equations of conics, and it says, I can tell you always, 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 always who will be who and what will be what. So if you're given the long drawn-out form of a conic, if A equals C and they're both plus, if A equals C and they're both plus, it's a circle. Why? Because it's an x squared plus y squared, like an ellipse, but if these are the same, they're going to have the same radii, so it's a circle. If they're not the same, but they're both positive and they multiply, you guys see how this is starting to get confusing?
So that's something
Well, this isn't on the formula quiz. Heck no, tech no. This is not in the formula quiz. It's not going to be on your formula sheet either. It's one way, and it's not a bad way. The way that I'm going to show you usually works. I'm going to show you when it doesn't work, but it usually works. Ready? If we think about all of our different sections, and I've been preparing you for this since day one. Section 10.1, ax plus by equals c. Isn't there just an x term and a y term and then a constant for lines? Cool. So just a coefficient of the x term, y term, and a constant. That's it. So no squareds allowed, right? You can think of like boys in a treehouse. No girls. No squareds allowed. Lines, no squareds. Parabolas. How many squareds are allowed? Just one, because you have to have x minus h squared with this 4p y minus k, or y minus k squared with this 4p x minus h. Only one's allowed to be squared. So lines, no squareds. Parabolas, just one. Ellipses and hyperbolas, we allow two. We need to. But what's the difference in the formulas between ellipses and hyperbolas, besides that the a is sometimes major, a is sometimes negative? One's positive, one's negative. What does that mean?
It means a times c.
Like signs, not like signs. Not like signs, hyperbola. Like signs, ellipse. So then coming back. How many squareds do we have?
2.
Not line, not parabola. What are the signs? Same, or plus. Ellipse, or circle. Coefficients are the same. The a squared and the b squared would be the same number, which means, oh, it's not distorted, it's a circle. He's kind of weird. Coefficients are the same. But do you guys see how the squareds lead us to, and the plus and the positive lead us to ellipse?
Yep.
Without having to do all my x minus h squared and plus y minus k squared, all that jazz. But the coefficient's the same. Said not just any ellipse, it's a circle. 52. How many squareds? Just one. Parabola makes sense? 62, how many squareds?
2 squares.
2. Same or different signs?
Same sign.
Ellipse. Because the numbers are different. But what happened?
Wait. What happened? It's a negative.
Check it. Why is it? Look at the problem. We have typos in our book. We have typos in our book. Who can see the typo? Who can see it? No, just look here. Don't worry about the question. Look here. Where's the typo?
Plus 2x, that thing, I believe.
That's plus, that's minus. So you need to look in your question on number 62 as you're grading. What was it? Was it a minus or a plus? Okay. So the answer is correct, but is this correct? No. That's awful. This would be an ellipse, and we would be totally right. They wrote the problem wrong. So is it 4y squared minus 2x squared?
Yes. Yeah.
Good. So y squared's great with a minus. Great. Hyperbola. So sorry, typo. It was a negative. It's a hyperbola. How about number 66?
Ellipse.
Both squares with a true positive this time, not a typo. With different coefficients, it's an ellipse. What is the one time my shortcut of no squareds, it's a line. 1 squared, it's a parabola. 2 squareds with both positives or same sign, ellipse. As long as the numbers aren't the same, then circle. Both squareds with an opposite sign with a minus, that's a hyperbola. What's the one time that doesn't work? Do you guys remember yesterday? Degenerate. Because look. 2 squareds minus, it's a hyperbola. My trick works as long as it's not a degenerate. So what does that tell you about the test? Well, okay, set you up for failure. If you don't have a lot of time, use the trick to answer as best you can. But if you have extra time, go back and make sure it's not a degenerate.
There's no option for degenerate.
Well, that's true. Well, no, that's smart though, right? Have you guys ever done that, like narrowed down the answer from the answer choices? I mean, that's okay. But what could the degenerate answer look like? How about a none of these?
Yeah, it could.
All right.
Just be
There you go. Good job, Joe. I agree. Huh? Well, aren't they really easy questions in some ways? But because they're really easy questions but can still be a little bit tricky, I don't count these ones. I think I have 2 or 3 on the test. They're not worth whole problems. They're worth half problems. So that way it's like, yay, I'm getting easy answers. But if you make a quick mistake or if you don't catch a degenerate that might or might not be there, maybe I'll give you more hints as the test comes closer. I don't want to necessarily take away tons of points because you missed multiple choice questions. Okay. Guys, it's been all well and good, like reviewing, talking about the test and doing section 10.4, and I'd love to go over questions, but what are we technically supposed to cover today? 10.5, nope. Oh, not 10.5? It's not totally bad. I didn't write it up here. Does our book have a 10.5? Yes. And our 10.5 says something to the effect of, let me show you up here, if I can get there. Aha. Okay, do you guys see what the title is? Bleep, bleep. Oh. Rotation of conics. Rotation? What do they mean in our book by rotation of conics? P.S. Please don't write this.
Oh no. Oh, so it's angles?
So all of a sudden, what was the XY, what was the major and minor, just got twisted. Rotation, okay, I get it. The axes got rotated. But actually, in context of what I need you to be able to do in calculus, or what other teachers would need you to be able to do in calculus one day, this is good for physics. It's just not that great for calculus, because you're not going to, in the introductory calculus, see rotation of axes. Instead, you're going to see from another book that has chapters a little bit differently ordered, from another book that has chapters a little bit differently ordered. Well, I'm not giving you the other book. I'll show you what I'm giving you in just a second. But we are going to be rotating. You guys see the word rotating? Yeah. We are going to be rotating, but not the axes with an angle with like trig stuff coming back. Instead, we're taking the conic, and I wish I could show it to you, except someone broke it, and then I gave it to a certain teacher to try to fix it. I never got it back. We're going to be rotating our conics themselves from the second dimension to the third dimension. So take an ellipse, boop, boop, and spin it. What do you get?
Still the same.
Kind of like a football. Well, like a sphere, but squished. So we can't call it a sphere. If we rotate a circle, we get a sphere, right? Not rotating as in like, but rotating as in spinning it. We get a sphere. But if we rotate an ellipse, we get an ellipsoid. If we rotate a parabola, we get a paraboloid. And if we rotate a hyperbola, we get a, did you follow the pattern? Hyperboloid. Oh. And if we rotate a line, a linoid? If we rotate a line, huh. Yeah, another line, right? Because it would come over on this side. Wouldn't it come over? But then wouldn't it also come over like all the way around?
Yeah.
And make lines like all that way? And we would have lines, and we would have lines, and we would have lines, and we would have lines. We would end up with our double naped cone that all our conic sections come from. So all the conic sections really come from a line that's been spun. Go, team. Ready, set, notes, go. All the conic sections really just come from a line that's been spun. I would say call it 12.3a, but put other book. Otherwise, some of you are going to be going to chapter 12 to look for homework. Don't do that. Yes, we're getting to chapter 12 because we're skipping chapter 11, but not right now. Wouldn't really be helpful. But can I show you Google Classroom real fast to try to make this a little bit easier? Because some of you guys are like, wait, I can't go to my book. No, you can't.
How do we check our answers?
Yep, I got you. Do you see the homework that is posted in Google Classroom? Do you see how there's a, 12.3 other book? Hey, it's his section. You see it? Okay, so it's the section from the other book, but some of you are like, but wait, no, I was asking about homework. Oh, that's right. Other book homework handout. I'm not giving you the actual paper because you guys are going in Google Classroom anyway, so why not just look in Google Classroom? Anyway, so homework. This is the other book. Oh, hey, I even circled things for you. You're welcome. But anyway, homework. But then that wasn't actually Priscilla's question either. She said, because she was very focused, how do we check our answers? Meaning check. She said check, not find, not steal, not cheat. But how do we check our answers? Aww, it stops there. But wait, did you realize there was more to this one? You're welcome. Boop. Okay, ready? Maybe. Maybe not.
I mean, sometimes it works.
Joe, if you're writing, I don't mind if you're talking. As well as the people that you're talking to. If they're writing, I don't mind if we're conversing. Just the majority of us don't multitask well. Truth. Sometimes it hurts. If you don't acknowledge it, well, you could get led astray. Oh, led astray. Astray, old term. That means? Do you guys know what led astray means? Yeah. Led in the wrong way or the wrong direction. We're trying to think about puns back there. From Avatar? No. I knew about it. Kids would talk about it. Yeah, kids would talk about it.
They were trapped and by some crazy dude, and they're like, "Let us leave." And he's like, "Let us leave?" We need to leave.
It's very clever. Did they draw attention to it, or did it just happen?
They draw attention to it.
Oh, okay.
Except it's not on any sites, so I had to binge it illegally.
There are consequences to your actions. Let's keep going. I can do this all day. Do you guys see there's this snazzy term for these rotated conic-y things?
Analog. Wait, is it analog? You have a signal?
Pause.
Opposite to
You zoomed in on one word, Joe. Zoom out. Big picture. Zoom out. What's the term for all these rotated? Quadric surfaces. I know. See, your brains just made it a quadratic randomly. Nope, it's not a quadratic. Quadric.
quadric surface.
Not a quadratic.
If Miss Dewick would have called it quadratic, we never would have known.
Yeah, you never, and then you would have been thinking they're all parabolas and then confused they're not. Although there are squares, but no.
Parabolas from it.
Yeah, that's true. But they're not all just parabolas, right? Quadric surfaces. A 3D analog. Analog is like a generated by a conic section. And you're thinking generator, like signal, kind of has to do the same thing.
Whole signal rather than digital signal.
But that's not what this one is talking about. So the definition of analog, either it's used in a different way, Joe, or I wish I knew more in order to be able to draw the connection. In a lot of things in math I can, but the actual word analog I can't.
Analog versus digital.
Right, no. I know the difference between analog clocks versus digital clocks, right? Like, what I mean is I don't know enough behind why it's called analog to go ahead and compare it to this. But what I am saying about this is, a three-dimensional analog of a conic section is like a three-dimensional generation. No, in this context is a three-dimensional generation of a conic section. We can talk more about how analog actually works, and I can try to find some sort of connection, or we could just Google define analog and see if it makes sense. But anyway, defined by quadratic equations in three variables. Sorry, there we go. So wait a minute, does quadric have to do with quadratic?
It looks similar.
They both say quad. So is that like 4? Yeah, I think so.
Do you guys see how this is not quadratic, but that is?
Wait.
Quadric surfaces are defined by, generated by, quadratic equations in three variables. What does that mean? Quadratics, like quadratic polynomials, are x's squared. The variable it's in terms of is squared. But these equations are saying basically still the variables can be squared. What are you looking for, bud? What?
Can I get a paperclip?
Yes, I'll get you one. Little or big? I'll bring it to you. Little or big? Oh, you just need to pick off gum? Okay. Quadratic, we're talking about how everything could be squared. Doesn't have to be squared, but could be squared. So x could be squared, y could be squared, and z could be squared. So the quadratics we're used to are technically y equals x squared plus bx plus c, and that's all we got. But these quadratics are actually x can be squared, y can be squared, and z can be squared. And we kind of know the x squared, y squared from ellipses and hyperbolas. But these are not called quadratic surfaces. Even though they're built upon quadratic equations, they're only called quadric surfaces. Now, bloop, 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 bloop. Joe, just because I barely have any time, I'm going to have to say later, okay? Generated by rotating conic sections about their axes. Now, real quick before we go into the paraboloid formed by a parabola, a couple things. Surface region. Think about surface area. Surface region, think about surface area. Solid region, I want you to think about volume. For the surface region, it might be helpful to think about a shell of something versus a solid region. Well, okay, this one's kind of lame because it's in the name. The solid. So the surface is the shell, the solid is the solid. What am I talking about? The surface of an egg could be like the shell, right? And the solid could be, think it's a boiled egg, it's all the stuff on the inside. True? So when I'm looking at these quadric surfaces, we're typically just sketching the surface. We're typically just sketching the shell. That doesn't mean that we couldn't ever think about the volume, think about what's inside once we get the shell. But we're technically just thinking about the shell. So when you guys are looking at, oh, sorry, let me look at the book because there's more pictures. This one, you could think about this just being the shell, or you could think about it being filled up with either liquid or like it's a solid block and being a solid. So there are different ways of thinking about it. This one, you could think of it as just being the shell, or you could fill it up, just being the shell, filling it up. But most of these that we're drawing, guys, we're just drawing the shells. You can kind of see different representations, but anyway, we're not going to go too crazy into all of that. This one, once again, I think we're pretty much just dealing with shells unless they say the word volume. Okay, so sketching the shells or sketching the surfaces of these quadric surfaces. Did we just spend section 10.2, 10.3, 10.4, or even going back 10.1 to getting very precise graphs of conic sections? We did, like with certain A's and certain B's and certain this and certain that. But in order to make it super specific, didn't we have to have very specific equations to work from? We've done that. We've been there. I just want to expand your understanding real quick before showing you homework. I want to expand your understanding. What if you've done all that work and you've gotten a parabola? How do you rotate it and what can result? How do you rotate it and what can result? Did I never give you that paperclip, Jason? I got it. Oh, he has it. Okay. I was thinking I gave it to you. So let's say you sketched a parabola. Now normally, let's just put the center, I should say, I apologize, the vertex at 0, 0. Let's just make it kind of like a normal y equals x squared. Let me make it a little bit smoother too. I was not connecting it very smoothly. Okay. Let's say we have kind of like a normal parabola centered around with the vertex at 0, 0. Okay. Normally, wouldn't we put little arrows and say, hey, you keep on going forever? Yes. But in all the pictures that we just saw, did those quadric surfaces keep going forever? No. So somehow in homework, they're going to have to give us some sort of restrictions, usually with like little x values one direction or little x values the other direction. They're going to tell us to cut our conic or to stop our conic at certain points, just to be defined by certain boundaries. That's more to an actual like shape or figure that we would ever see. So we're going to cut our conics, and then we're going to ask ourselves, okay, if we're trying to rotate conics about their axes, parabolas only have one axis. Now, I know it has a directrix and it has a focus, but pause. Just the shape itself, what axis does a parabola have? This one will be y, and it's called the axis of, Matthew's got it, symmetry. It's called the axis of symmetry. So in this one, the y-axis is the axis of symmetry. And some of you that are more visual will understand this better. Some of you that are more artistic will enjoy this better. But I want you guys to go ahead and learn how to draw what we call a rotation arrow. It's the idea of, hey, this is the axis that is going to be spun. So if we could pull this right now off the page and have like some sort of representation of this guy and representation of the axes, if it could have depth and I could pull it out, what would I start doing? spinning it. So I'm twisting the axis, I'm spinning the axis, I'm rotating the conic. What shell, what figure would be generated if, as I spun, it would form, it would create a shape? You see it? Yeah, kind of like a teacup. But with like a bowl bottom and no handle. Anyway, paraboloid. And if you want, you could have some snazzy fun with it. You could even like form a z-axis if it's cool. If you have that sort of perspective, you could actually show like a parabola that would be on the other side. You could have fun, and you could do like what the book did, and you could connect their axes. You could do things like trying to, and you guys with pencils will be much prettier than me with my smartboard pen. You could show that rotation. You can have fun with it. But my non-artistic people, literally what did we do? We had a parabola. You show your rotation arrow and you say, yay, I rotate. It's not great, but I see it, and you did a good job. And yeah, it's called a paraboloid. Now, pause. Did you see my rotation arrow? And did you see the rotation in the shape? Okay. Artistic people, non-artistic people. Really artistic people, so much better than mine, but you do you. That's a paraboloid. What's our next conic? Section 10.3. You've already seen the line. If we spin the line, we get like a double-naped cone, but ellipse. Okay, here's Dilio. Depending on all the information or all the stuff you might have done to begin the homework to get the very precise ellipse that they want, because real quick in the homework, sorry, this is the section. Let me get out of that real fast. Here we go. Do you see how they're giving you actual equations? How would you graph these guys? This one's going to be an ellipsoid because it's an ellipse. Couldn't we, hey, isn't it centered at 0, 0? No completing the square necessary?
Yeah.
Praise Jesus. But do we still need to divide the 16 and find the A and find the B and graph it? So you would have to graph the ellipse first, or the hyperbola first, or the parabola first. But once you have the ellipse, couldn't it be squished this way or that way? Okay, you guys tell me because I can do it either way. Both of them have majors and minors, and that's the point. Which way do you want this ellipse to go? Horizontal? Cool. So let's draw a horizontal that somehow goes out farther than it goes up. That somehow goes out farther than it goes up. Now I know, I'm cheating. I have a smartboard, but I'm going to come over and copy and paste it. That way they're pretty much the exact same ellipse. So let's say we've done all of our work. We've gotten this nice ellipse. He has a major axis of the horizontal or the x-axis, right? And he has a minor axis of the y-axis. So if quadric surfaces are formed by rotating conics about their axes, couldn't it 1 second be rotated around its major axis, and the next second be rotated about its minor axis? Okay. What happens if we rotate him about his major axis? Do you guys see this circle, this rotation? Couldn't I show this rotation here? And I could show it here. I could show it here. And I could, if I wanted to, be super snazzy and show the spinningness. But either way, I take it and I spin it. My non-artistic people, ready? My non-artistic people, you spin it around its major. Ready? It's not great, it's pretty awful actually, but that's okay, it works. My non-artistic people, do you see how the rotation arrow is just brought into the shape?
Yeah.
That circle, that circular is just brought into the shape. Okay, but down here, this one's a lot harder. I'm going to draw it and I'm going to try to show it, visualize it for you. By the way, are you guys realizing there are names to these? Prolate versus oblate? Obtuse? Oblate? I know I'm not so great at this one, especially when I'm,
Just turning it the other way.
Yeah.
right?
Around the other.
And couldn't I?
Wait, what?
Whoa.
Yeah. Wait, why is that one connected?
Oh, I see.
Not very artistic.
Isn't it just like sideways?
What happened?
Oh,
What happened? Fan blade. What happened? Cheese wheel. What happened? One of those awkward little, like, this kind of pillows on your mom's chair or couch. Anyway, fan blade. Why? Because this came out. Right? It came out. It came out. This one's just like, oh, it's spinning like a football. Hey, pro. Football. This one. Oblate. Large. Out. Obtuse. Fan blade. I don't know. But anyway, my non-artistic people, because you're like, ready? Wasn't it like this? And weren't you spinning it like this?
Yeah.
So ready? You do one of these and you do like a yay.
Oh.
Uh-huh. See it? The rotation arrow got hidden.
But like, so this is the list, it's going like this.
Yeah. Well, it's going like this. Yeah, so it's going. I'm pulling it out and I'm spinning it, and as I'm spinning it, it's coming like it's flipping around. I'll try to have it on strings tomorrow so we can see it. My poor little dead, really cool illustration that used to work no longer works. What are we missing?
Homework.
Hyperbola.
Lloyd.
Loids. But wait, did you guys notice where homework starts?
One.
Paraboloids. Ellipsoids.
Hyperboloid.
But what do you have to do before you ever spin it? You gotta get it. Could you go get all the two-dimensional ones and then just spin them tomorrow? Bye, guys. Bye, one.
Miss Steve, if it's the same ellipsis,